Okay, number one, part A is 2.76 seconds. Part B is 64.6 meters. Part C is 9.29 meters. Number 2A is 4.78 seconds. Part B is 64.5 meters. Part C is 27.9 meters. Number 3, part A is 3.4 seconds. Part B is 58 meters. Number 4, part A is 57.9 meters. And part B is 10.1 meters. Anything you want to go over? Brayden.
Can you just go over the sig things in number 3? 3A and B.
Okay, so do you notice how the angle is 45 degrees? That's why I did everything with 2 sig figs, because after I do my calculations, I end up with 2.
Okay.
All right. Caroline?
I'm having trouble with the DYs. Can you do like one? Like, can you do just one of the DYs?
How about the first one?
Yeah.
So there's 3 different ways you can get to dy when you do it at the end. You know you have to use the vertical direction, right? So the values in the y direction. So there are 3 possible ways you can find it. I guess I don't have it open yet. So let's go over the 3 different ways you can get it. So 3 possible ways you can get dy. The first is using the equation that is written for d. That looks like this. The key here is that when you plug in time, that time must be the time up, not the total time. So you have to make sure that's the time up, not the total time. A second way you can do it is by using V bar is D over T. So D would be V bar times T. Now, if you do this, the V bar is the average of the VI in the Y and the VF at the top, which you get by adding and dividing by 2. And this time must be the time going up as well, half the total. The third way you can get it is by using the equation VF squared is VI squared plus 2AD, which means that D is VF squared minus VI squared over 2A. And since VF at the top is 0, that goes away. So can you tell me which way you attempted to do it?
I did it the first way.
This way.
Yes.
Okay, so in number 1, part C, that means you would be plugging in the VI of 13.5 meters per second in the upwards direction times the half time. The total time was 2.76 seconds. That comes from the time up of 1.38 seconds. So you should have plugged in 1.38 seconds. Plus 1/2 of negative 9.81 meter per second squared times 1.38 seconds squared. And so if you do that, that's going to give you the answer that I gave you of 9.29 meters for number 1C. That makes sense?
Yeah.
Okay. Anything else you want to ask about? No? Okay. You may use your homework. You'll need your reference table and your calculator to help you with this quiz. It is a show work quiz, so make sure you just read the question carefully, showing me what I asked before. And when you complete the quiz, raise your hand so I can come collect it. You do not have unlimited time to do this quiz, so pay attention to what's being given. You're welcome. One is fun. Once I have your quiz, you can put everything away except for your Chromebook and open up to Lab 11. All right. So, folks, please open up Lab 11. Lab 11 in our Google Classroom. And when you have it open, there's two things that you need to open that go with that assignment. The first, of course, is the Google Sheet that is linked to the assignment. That's what you're going to turn in when the lab is done, is that Google Sheet. But then, in addition, you're going to see the simulation is also linked. This right here, go ahead and open that up. And if you're having trouble opening it, let me know. Some of the students in my last class were not able to open it up. The firewall was blocking it. I don't know. They must be troubled kids. Always doing stuff on our network that they're not supposed to be, that they were blocked. Okay. Let me walk you through what you're going to do in the simulation first, okay? So, do we all have the simulation open? And you're looking at this screen? Okay, go ahead, click intro. This is the same simulation we used for the other lab where we were firing things off the cliff. There's no cliff in this lab. So I want you to grab the cannon, bring him down to the ground. I also want you to adjust the angle that the cannon makes with the horizontal. Can you increase that, please, to 45 degrees for part 1 of the lab? And what we're going to be doing in part 1 of the lab is varying the speed at which we launch the pumpkin out of the cannon. Okay, so we're going to start, if I look at my Google Sheet, go to part 1, where it asks for the effect of the initial speed. We're going to be testing all of these different initial speeds that are here. So the first initial speed that we want is 3 meters per second. So in our simulation, go ahead, reduce the speed down to 3 meters per second. I'm going to do the first couple with you, and then I'm going to ask you to pair up with somebody and get the rest of the data. Okay? So go ahead, launch it at 3 meters per second. It's really tiny, right? You can make it larger on your screen by clicking that plus sign magnifier glass. That way you can see it a little bit better. Now grab your blue measuring tool like we did in the last lab and bring it down to where it hit the ground. And all of a sudden, you'll see a little yellow dot that lights up when those crosshairs are at that dot. You should also see that the height at that position is 0 meters if you are in the correct spot. Now, the hang time we can see is 0.43 seconds, and the range is 0.92 meters. Are you getting that as well? We should all get the same thing. Okay, so let's go back into the Google Sheet and type the hang time, which is 0.43 seconds, so just 0.43. The units are up in the column heading, and the range was 0.92 meters. Okay, now to get the maximum height, grab this tool, and you see at the top of the parabola, there's a green dot. You see it? That is where the crosshairs have to go. At that green dot, you'll see it light up, and then you're just going to take the height, which was 0.23 meters. So let's type that in for the height. Now what we're going to do is increase the speed up to 5 meters per second. So let's repeat that. Increase your speed to 5. Fire it. Move your blue measuring tool down to the bottom where the pumpkin smashed into the ground. You should get a time of 0.72 seconds. You should get a range of 2.55 meters. Now, to get the height, remember you're going to move that blue measuring tool up to the green dot at the top. Let that light up and then get your height, which should be 0.64 meters if you've done it the same way as me. You understand what you have to do? Okay, let's take a minute, team up with somebody and collect the data for that table. Maybe one of you is doing the hang times and ranges. The other person is doing the heights. That way you're not constantly moving the tool. I don't know. Or you split it up. I'm going to do 7, 9, and 11 meters per second. You do 13, 15, and 17, and then share your data so we can move along a little quicker, okay?
Okay. 17. What'd you get? I was looking at time.
Well, where'd the other one go? Seven.
Yeah.
How we doing? We good? Anyone need more time for part 1? Okay, let's go back to the simulation. We're now going to do part 2. In order to do part 2, you see how on the bottom right of your screen you have that counterclockwise orange circle or arrow? Click it. It's going to reset the simulation. I want you to bring the cannon back down to the ground. In this part of the lab, the speed is not going to change. What we're going to test is the angle. And if I look at the Google Sheet in part 2, notice that the first angle we're going to test is 30 degrees. So in the simulation, let's adjust the barrel of the cannon to 30 degrees, fire it. And we're going to use our blue measuring tool to measure the same 3 things: hang time, range, and height. So let's get our first hang time of 1.53 seconds at 30 degrees. The range there is 19.86 meters. And then the maximum height at that green dot in the center of the parabola is 2.87 meters. I'll do one more with you, and then I'm going to turn you loose again to team up and get the rest. So let's look at 40 degrees in the simulation. I'm just going to increase that angle to 40, fire it. And let's measure the hang time together. Should get 1.97 seconds. A range of 22.59 meters. And then the height is in the middle of the parabola at the green dot, 4.74 meters. You understand what to do? And you're going to go all the way down to 90 degrees. So maybe team up, split it. I don't know, something. Okay, share, help each other get the data. It's kind of cool about that, as you can see all the different traces as you shoot it. Okay. Can we go on to part 3 now? Yeah? All right. So let's look at part 3 of the lab here for a second. Part 3, we're testing the effect of air resistance. So here's what we're going to do. Let's go back into our simulation, please. And I want you to reset it again. Bring the cannon back down to the ground. And we're going to start with a launch angle of 35 degrees. We're just going to fire it like we did before. Let's get the hang time and range for this and height. So the hang time is 1.75 seconds. The range at 35 degrees is 21.55 meters. And the maximum height at that green dot in the center, there it is, 3.77 meters. Now, do you notice the next row, there's something different here in the table? It says air resistance. Yes, we're going to test air resistance. So here's what we do in the simulation. To now test that same thing with air resistance, on the top right of the screen, do you see it says air resistance? There's a checkbox. Click the checkbox. And now fire it. And you're going to see the trace is now in pink instead of blue. Yes? Okay. What we're now going to do is grab our blue measuring tool, bring it down to where it hits. I got to zoom out. There we go. You can see that the hang time is now 1.7 seconds. So type that in, 1.7 seconds for the hang time. Let's get the range there, 19.2 meters. And then let's get our maximum height at that green dot in the center again, 3.54 meters. You can see that with air resistance, those numbers are a little different. Let's now do it again, this time at 65 degrees and then at 90. I'm going to let you guys do that. Okay, maybe split it up. One of you is doing air resistance, the other isn't. Or one of you is doing 65, the other's doing 90. It's up to you. Okay, once you have all that data, you can close the simulation. Just X out of it. Get it out of there. You don't need it anymore. It's taking up bandwidth. And you should be getting numbers similar to what I have, or the exact same numbers I have, because the data, same simulation. Okay? Anyone need more time? Let me maximize this window. Okay, once we are done with part 3, I want you to go back to part 1. Go back to part 1. And what we're now going to do in part 1 and part 2 are make the graphs. That's all there has to be done, except for then the analysis tab, which is just answering the questions based on the graphs that you have, which should be no big deal. I at least want to get through making all the graphs with you. Okay? Can we start in part 1 together? The first graph we're going to make in step 2 in part 1 is a graph of hang time versus initial speed. So select where it says initial speed in meters per second. Hold down your shift key. Right arrow over to hang time, and then down arrow to get all those numbers. So you have that blue box. Go to insert chart. The chart type is incorrect. Select scatter, the one on the left. Now go to customize. Chart and axis titles. The chart title is hang time versus initial speed. Go to the horizontal axis title. This is initial speed in meters per second. Your vertical axis title will be hang time in seconds. Okay, collapse that menu. Now, notice that the horizontal axis does not start at 0. It needs to. So if I go to my horizontal axis submenu here, set the minimum value to 0. Okay. Now, collapse that. We got to add our trend line under series. Select trend line. And linear looks like a great fit, doesn't it? So let's leave that alone, but let's add the equation, which is under label. That graph is now complete. You can click it and drag it down into the space that goes just below question 2. I'm going to make my graph just a little smaller so it fits better. Okay? Can I go on to the next graph? Range versus initial speed. All right, so select initial speed in meters per second. Hold down your shift key, right arrow over to range, then down arrow till you get all those numbers. Insert chart. Change the chart type to scatter. Now you'll notice when you do that it gives you 2 things here, 2 sets of data points on the series. We don't want the hang time. So for those 3 dots, click them and say remove. So now you just have initial speed in meters per second and the range in meters. Okay? Let's go to customize it now. Chart title first. The chart title on this is range versus initial speed. The horizontal axis is initial speed in meters per second. The vertical axis is the range in meters. Okay, notice your x-axis does not start at 0. So if you select your x-axis, horizontal axis, you can set the minimum value to 0. Now let's add our trend line, which is under series. What do you think about linear? Good or bad? Bad, yeah. So click the down arrow. We always try power series next. Power series looks beautiful. Let's now change our label to use equation. Now we can click that graph, drag it down into the space for item number 3. I'm going to make it a little smaller so it fits in that yellow space. Okay. All right. One more on this tab, maximum height versus initial speeds. Select initial speed in meters per second. Shift key, right arrow over to maximum height, down arrow to select all the data. Insert chart. Change the chart type from column chart to scatter. Now, we do not want all of these 3 sets of data points on the graph. We do not want hang time. We do not want the range. We just want the initial speed on the x-axis and the maximum height on the y. Let's customize it with our chart and axis titles. Let's start with our chart title. This is maximum height versus initial speed. Let's add our horizontal axis title, which is the initial speed in meters per second. The vertical axis title is maximum height in meters. Okay, next issue is again the x-axis does not start at 0. So change that horizontal axis, set the minimum value to 0. Now we can go to our series option to add the trend line. Linear is not good. So what am I going to try next? Power series. Power series fits it beautifully. So now say use equation for your label. That graph is now done. Let's bring it down and put it in the space for item 4 on this page. That yellow shaded space. And that graph is finito. Okay, can I go to part 2? The graph's there. We have 3 more to make and then we're done for now. And you'll finish it for homework. Let's go to part 2, effective launch angle. So in step 2, we want to make a graph of hang time versus launch angle. So select the launch angle in degrees, shift key down, right arrow over to hang time, down arrow till you get all the numbers, insert, chart. Same issue. We don't want column chart. We want scatter chart. There's only one set of data points, so that's good. Go to customize it. The chart title. The chart title is hang time versus launch angle. Now let's go to the vertical axis title. This is going to be the hang time in seconds. The horizontal axis title is going to be the launch angle, and you have to spell out degrees. Now notice again, the horizontal axis is not starting at 0. So we're going to set the minimum value on our horizontal axis to 0. Now we're going to add our trend line under series. What do you think about linear? Right? It's So let's try power series next. That's also So what do you think we should try after that? Polynomial. Yeah, give that a try. That fits it nice. So let's go with polynomial. Change the label to use equation. That graph is now done. We can click it and drag it down into the space for item 2. Okay, now we're going to do it range versus launch angle. Let's go on up. Select your launch angle in degrees, shift key down, right arrow over to range in meters, down arrow to select the numbers, insert, chart, change the chart type to scatter. I hope you know what you're doing by now. Come down to series, get rid of hang time. We don't want hang time on there, just the range. Customize it, chart and axis titles. The chart title is range versus launch angle. The vertical axis title is the range in meters. The horizontal axis title is the launch angle in degrees. Now collapse that. Horizontal axis is not starting at 0. Go to your horizontal axis, set the minimum to 0. Now we're going to add our trend line under series. What do you think about linear? No way. So what's next? Power. That's not good either. So what do we go to? Polynomial. That looks better. Add your equation. And then that graph is done. When we come back, we'll do the third and final graph for the lab, okay? So go ahead, take a quick break, stretch. If you leave the room, make sure the foot is down on the door so you can get back in. A little repetitive making these graphs, but you should know what you're doing by this point. Here. All right, let's get you folks done with this last graph. I'll walk you through it real quick. So we're making a graph of maximum height versus launch angle. Head on up. Start with your launch angle in degrees. Shift key down. Right arrow over to maximum height. Down arrow to select all the numbers. Insert chart. Change the chart type to scatter. Get rid of hang time and range from the series. So it's just launch angle and max height. Let's customize it. Chart title should be maximum height versus launch angle. The vertical axis title is maximum height in meters. The horizontal one I just lost it. The horizontal one is launch angle in degrees. Notice your x-axis does not start at 0. So set your minimum value on the horizontal axis to 0. Let's add your trend line under series. Linear is not great. Let's see if we can do better. Try power series. And that's not much better. So let's try polynomial. That fits it much better. Let's add our label, use equation. That graph is now done. Please click it, bring it down into the space for item 4 on this tab. Okay, that is everything that you need to do to answer the questions on the analysis tab. Notice the first 3 questions are from part 1. The next 4 questions are from part 2. And the last 3 are from part 3. I'm not going to answer those with you. I would like you to do that for homework. Just answering those questions for homework based upon the data you see in the tables and the graphs you made. Can you please close that out and put away your Chromebook? Our next lab is not a virtual lab. So let's close out the lab, get rid of it. You're going to finish it for homework tonight and turn it in before class starts tomorrow. Our next lab is a regular lab on paper. You need to clear your desk of everything but pencil, reference table, and calculator. I'll give you the lab worksheet here, and I'll walk you through what we're going to do. You're welcome. This lab is going to test you a little bit on your knowledge of angled projectiles. That's why lab 12 is called angled projectile. Okay. Make sure you're doing this in pencil. No crossouts, right? We don't like crossouts. Okay, so on the top of the lab where it asks for your name, please put your name in pencil. This is lab 12. Please write the lab number on the line where it asks for it. What we're going to do right now is collect data that's going to go in table 1. We're going to do this as a class using the setup that I have up here in the front of the room. I don't know if you can see it. Over there, I have an angled projectile launcher. It's going to shoot this projectile, and it's going to hopefully land in this landing zone that I made on the floor. On the floor, what I have are 10 pieces of copy paper in a rectangle. And what I'm going to do on top of that paper is I'm going to tape them down so they don't move as we walk back and forth. But I'm going to take carbon paper, which is just paper that has ink on one side, and I'm going to place it with the ink down on the paper. So that way when the projectile lands on it, it pushes the ink onto the paper below it. So we'll have a mark. Kind of like if I were to do this, launching it into a sand pit where it hit, we would see a little dimple in the sand, hopefully. I don't have a sand pit, so we're doing it this way with carbon paper. That's what we're using. So what I'm going to do is just tape these down so each piece of paper here does not move. Hopefully. It doesn't need to be perfectly still, but pretty close. And then what I'm going to do is I'm going to get a stopwatch up on my computer. And that way we can all look at the stopwatch on the screen together. So that way we can get our times, the hang time from when we launch it there to when we hear it hit. That would be its landing time. Then, once we have done our 3 trials for the hang time, then what we'll do is I'll take the carbon paper off, we'll see the marks, and then we'll just measure all 3. I have a metric measuring tape here on the floor that's been taped down in place. All right, and here goes the carbon paper. Gianni, would you like to fire the projectile?
Sure.
Okay, so that's going to be your job. And I'm going to get other people to come and make measurements. So I'll show you how it works. In just a second. We just get the carbon paper backwards. I need 2 more sheets of carbon paper. Can you feed this onto that metal rod?
Yeah.
Got it? All right. Now let me show you how we get this loaded. So you see how there's a hole here?
Yeah.
You just pull that back into this clip, and that will hold it.
Okay.
And when I tell you fire, all you're going to do is push that clip down, and that will force it out. Okay? All right. So let me get a stopwatch up here. I'm the one who's got to make sure I don't mess up. Okay, here is the stopwatch. So when I tell you to, I say fire, that's when you're going to push that down. You ready? Ready, set, fire. Oh, shoot. We're going to do that one again. See, I messed up. I wasn't where I needed to hit pause. Let's try that again. So now we'll have 4 marks. That's all right. Not a big deal. Ready, set, fire. Okay, there's our first time. Don't worry, we'll get your times down in a minute. Go ahead and write that time down for the time for trial 1. Let's reset it. It's landing in that zone, isn't it?
Yeah.
Good. I thought it would. One year I did it like 10 times and not one of them landed in the zone. I was heard a lot of 4-letter words that day. Okay, ready, set, fire. There's the second time. All right, one more, Gianni. You ready? Okay, ready, set, fire. There's the third time. All right, thank you. So let's get these times down. And we should all have those times, yes? Okay. Now, before we average them, let's see. Where are the marks? Yeah, we'll see here should be on one piece of paper. There's one. Oh crap.
Is it cool?
I only see one.
Gianni.
No, it's not his fault.
Jenny would
Bet you it was hitting the measuring tape where I don't have carbon paper. Well, you know what? We're just going to use it all 3 times. We're going to just say we're pretty good. I'll just tell you what they are. All right. So 2.44. The next one is 2.45, and the last is 2.46. Okay, so please average those numbers, please. Please, please. Remember, the averages have to go to the hundredths place, just like the raw data. What do we get for the average time? Good. Now let's do our range. What's the average range? Yep. Okay, these 2 numbers are now going to come over here. That time is 1.19 seconds. The range is 2.45 meters. Now, let's think about the DY for a minute. This is from launch to landing. It starts on the ground and it landed where? So what is the vertical displacement from launch to landing? 0. Okay. Now, let me explain what you're going to do for the rest of this. Front and back. Questions 1 and 2 are just questions. Anytime you see something that says calculate, let me explain what I want to see. If it's a calculate, you need to show me the equation. If necessary, the algebraic manipulation of the equation, your substitution with units, and then you'll need an answer with units and sig figs always. Okay. So based upon what I see here, how many sig figs is everything going to end up with?
3.
3 on the time, 3 on the range. Okay, so now, before we get going, it may be advantageous for you to make the chart. What do we know about the X and Y directions to help you? We should be able to put accelerations in there, which you'll be filling in certain things as you answer questions. Then, of course, our next row are the initial speeds, the displacements, and the times. The D in the X direction you have. So let's fill that in. 2.45 meters. We also have the D in the Y direction right now. 0 meters. We also have the time. 1.19 seconds. The other stuff you'll be determining in the lab. Okay? Yeah.
Oh, wait, never mind.
Right? Because, look at what question 1 asks for. It wants the A and the X. Once you have it, you can put it in the table. What's number 2? It's A and the Y. Once you have it, you write the answer here. You can put it in your table and then use the table to help you do the other calculations. Cool? I am not doing any more with you. Pair up, work with somebody, work on trying to get it done before you leave. If it is not done before you leave, not a problem. You just got to finish it for homework. And then I would collect it at the start of class. If you finish it before, then you can go back to that other lab on the Chromebook and finish that too. Okay? I will leave you guys alone to get that all done.